Alright, hello everyone. So, I'm gonna showcase today the implementation of the particle system I have made for the Magicka Blender exporter. So, let's get inside and showcase something very simple, right? So, the textures are missing again, sorry about that, but I did not link the file properly. Anyway, as you can see, we got particles going on. Yeah, pretty cool, huh? Look, my hat is on fire. So, this was quite an interesting journey because it wasn't really that hard to get them working, but there's a bunch of interesting details about this. Okay, so let's get started with them. Okay, so here we are in Blender, right? And this is the level that I've been showcasing. And these things right here are the particles, right? I have pretty much made them be a new type of empty, quote-unquote selector, let's just call them, right? So we go ahead and place a new empty of any type. When we go to the Magicka panel, we can see that we got the non-type, which is, you know, regular locator used for whatever you want, just a regular Blender locator, right? And we also have the types, well, locator, sorry, empty, right? Just naming them locators as they are in Magicka, but it's not the same. Anyways, we got the locator type, which is pretty much what you can use for spawning NPCs. We just say this is the location where you're gonna spawn, or an event's gonna happen, or spawn a particle here, whatever, right? The trigger. And we also have now a particle, which they are called within Magicka's code in multiple ways. They are named effects, which is kind of weird because XNA materials are also named effects, so it's a bad name. And in other parts they are called visual effects, which it's not really a good name either, but still a better name than just naming them effects. So for the sake of clarity, since they are particle effects, I'm naming them particle, right? I could just actually name them particle effect for further clarity if anyone thinks it is necessary, but you know, this is what it is, right? And these particles have a bunch of properties. So as you may have seen, there is a particle field which by default contains the value ambient fire torch, right? And this right here, it contains basically the name of the file that it's going to be getting used by Magicka when you generate this particle, right? So when we're in game, this is going to look up a file that contains the actual particle that is going to be seen by Magicka, right? And the range field, I haven't really tested what it does yet. I know that Magicka reads a range field in game, and that's why I added it, but I didn't experiment with it yet because I was more focused on fixing an issue with the rotations that I will explain in a while. It might have to do with the size of the particles. Maybe it's actually the scale or something. I don't know. Or some color mapping stuff. We'll figure it out in this video actually. But the thing that I wanted to show is this thing right here. If we go over to the in-game files in the content folder in Magicka, we can see that we have this right here, which is, you know, we got our levels, languages, FBX, whatever. And right here we got effects, and effects is the folder where you want to go, because in effects we have a bunch of XML files of all types which correspond to a particle effect. And if we go into ambient, we can find some common infinitely playing ambient particles. You know, most of the ambient particles are those that are going to be playing in an infinite loop, such as, you know, fire or whatever. We got fire blue right here. We'll try this one out. So if we look over here, we got our ambient torch somewhere, right? It's named ambient fire torch. So we got ambient fire torch. So this one right here is the file that corresponds to the particle that is being used by default, because you know, it's the one that I'm using by default because it's the one that I extracted from, you know, the with Sir Castle level 0 from the base game. So if we open this file right up, well, you can see it's got the copyright from Arrowhead, blah blah blah. It's a regular XML file with the whole configuration of the particles. So this is its own file format and is actually part of the base game. So I don't really have to create anything. I mean, we could make a program to visually see what's going to happen and create our custom particle editor, whatever, right? But we don't really have to, because this entire file format is used by Magicka, and well, it's implemented by Magicka, right? So it's not really necessary for me to create anything else. No need to make custom JSON files or anything, because this is fully customizable from the XML side with the already existing stuff from the in-game particles. So that saves us a lot of work. Now, the only thing that you need to know if you want to use any particle XML file, whether it is from the base game or in the future, if anyone makes particle mods, you know, a custom particle, you just look for its name, right? And it has to be somewhere within effects, right? It can be in any subfolder. I suppose you could even make your own custom subfolders. The thing is that this name has to be unique and registered somewhere. And obviously the nomenclature that the people chose in Magicka at Arrowhead was to add the, as a prefix, the name of the folder, which it was to make it more, you know, unique. So it is impossible to have, you know, overlapping file names unless you accidentally do it. And if you make sure to always prepend the name of the folder to your file, then you sort of namespace it, right? So we can put anything we want. As you can see, it's in lowercase, because if we go over to the code from Magicka, this is the exported JSON file from Wizard Castle level 0. Right here, it's in lowercase absolutely everywhere, right? So, or wait, no, this is not the Wizard Castle one. This is mine. This is the one. I just realized because I saw the file name. So as you can see, they got an effect ID, which is basically only the name of the torch, if you can use it for anything. Because if I recall correctly, animated level part references particles that can be moved by the animated level part only through its ID, and it contains no further info or something. I don't remember exactly. The point is that this is only the name of this particle, same way that in Blender this right here is named MT001, and this one right here is named particle torch 0, blah blah blah, right? So we come back here, the actual name is ambient fire torch, and this is where I got it from, right? So I haven't checked the code, but they are for, you know, specifically the decompile code for the section where it renders the particles, right? I just know that when you check the name for visual effect, if I recall correctly, it does actually pass it to lowercase invariant, right? Or maybe this one doesn't, but like there's a lot of parts of the decompile code where I have seen where names and IDs are actually passed to lowercase invariant. So in this case, the capitalizing doesn't matter at all, so you can just name this with full lowercase, full uppercase, whatever, right? I would do recommend actually getting in the habit of naming everything in the correct way, because I have found myself in the situation in the past reading the code where, if I recall correctly, it's triggers. They don't actually do the lowercase invariant stuff, so they actually are you know, case sensitive, or maybe it wasn't the triggers, but you know, there's something in the code that I remember reading a long time ago when I started this project that I know is not case sensitive, and another thing that I know is case sensitive, but I don't remember specifically what things they were. So in this case, I know the particles are completely case insensitive, and we could just take anything, right? And let's, for example, go ahead and add a new particle. We just go ahead and say ambient fire blue, right? We can just copy this name. We don't need to add the XML to the name, right? And we put it in here. So we got ambient fire blue. And we can put it in lowercase if we want, because from all the decompiled code I've seen, everything is in lowercase within the XMB files for some reason, so I suppose that the creators just prefer that, right? I do know that within the XML files there's a lot more inconsistency when it comes to what is capitalized and what is not, so probably this was generated automatically by whatever program they used for level editing, and the XML files they wrote by hand. So yeah, anyway, I mean with the code within the XML files, because the XML file names are actually pretty consistent, I think. I haven't seen anything that is not consistent. So let me just put this particle over here, for example, and we now have a blue fire, supposedly. And we should be able to compile and see what it does. So now that we're in game again, let's wait for OBS. Okay, so you can see that we got a blue fire over there, and I think this one is from Dungeons and Demons, maybe. I don't remember. It's been a long time since I played the actual game, right? I just came back to do some modding progress, and every single new hour I've had since the 90-hour mark or something has been just like literally modding. But yeah, we got there a blue fire particle, and we can place it anywhere we want, right? My hat is on fire. This is pretty cool. Yeah, it's pretty nice. And this is gonna be kind of stupid, but if I recall correctly, we can make blue lightning as well, but I don't think we can make blue fire. Or maybe we can. Yeah, well, kind of. We got blue spray of steam. Anyway, that's pretty cool. We can pretty much have particles now, and you don't need to do anything else. The files don't need to contain any extra data in the JSON other than the particle location and rotation and its name, because you know you don't even go through shared resources. These are all of the particles are resources that are loaded by the game automatically, right? I don't know if all particles are loaded when you start the game or when you start a map, or if when the XMB file is loaded when loading the map, it also loads the particle effects as it goes finding the names and just searching for the XML files. I have no idea, but I know that it loads it automatically. We should check in the future the code to see at what point it is loaded to optimize further stuff, I guess. But like, it's just done. It's there. It's automatic. You don't need to do anything else. And from the point of view of the user, there's actually barely any work to be done. Only placing stuff in the level editor, which is just Blender, and pressing export. So this is really nice. This is extremely nice, to be honest. Also, I wanted to mention one thing, right? Which is, let me go over to here in the code, right? So I mean, this might not be the best place to showcase, but anyway, basically I was making some tests trying to see what the rotation corresponds to, and as I said in the previous video, this thing right here clearly corresponds with a 45-degree rotation, right? Because if you've done any math with matrices and rotations and stuff, you may have seen this value pretty frequently, which literally corresponds to a square root of 2 divided by 2, right? Well, minus in this case, because it's negative. So at first I was like, yeah, this might be just a rotation, right? But like, if you try to pass this from radians over to degrees, you will see it's 40.5 whatever, right? So that's when it dawned on me, whenever we've seen these values, when we make a rotation through a rotation matrix, that is using the sine and cosine functions, right? And that is not how you store a rotation within a regular rotation vector, right? So it's kind of weird, but the way that it works, the rotations are represented in Magicka as a point, actually, which is a regular vector, right? This is through a vector that represents the orientation of the particle, right? So the way that we have to think about it to make sense of it is we start out with a vector that has the value 0, 0, 1, right? We start pointing in some direction, which is the initial orientation of the particle. So rather than storing just the rotation of the particle, what we're actually storing is its orientation vector, which is the forward vector, right? Or whatever vector, but you can think of it as a forward vector, and you apply rotations to that vector, and rather than storing the rotation that you've applied, like I rotated this many degrees on the x-axis, this many on y, whatever, what you store is the resulting forward vector of the particle, right? And at first I thought it would be a regular one, so that's why I put 0, 0, 0, and the particles were just not rendering. And I made a bunch of tests until I realized that thing about sine and cosine that I mentioned before on rotation matrices, and it made sense instantly. The value is a rotation matrix, right? And what this means, well, it's not exactly a rotation matrix, but like it's the result, the resulting point of a rotation matrix, right? And what this means for us, right, is very interesting. First of all, it means that if your vector, since this is an unitary vector, that means it has to have length 1, right? If you put 0 in it, you get a 0 length vector, so your particles are scaled down to 0, right? But if you make a larger vector, right, what happens? I haven't tested that, but potentially you could also store rotation and scale in here by scaling up the forward vector. I don't know if that works or not. I'm gonna test it out actually, right? But that's pretty interesting. I mean, it's a weird way to store rotation, but I guess it also helps encoding other information, right? Yeah, it's kind of weird. It's not really conventional, right? They just pick up a forward vector of sorts that's 0, 0, 1 and start applying rotations to it. But yeah, your particles don't really need to be rotated, by the way. I just see that I've got some rotations here, but they are all exactly the same visible. If we go over here, this one is rotated 0, 0, 0. This one are rotated in equivalent angles, because I was looking for what exact value they were using internally when I was debugging a problem that I have in a bug in my code, but that's fixed right now anyway. So yeah, you can pretty much just have them with no rotation at all and it would work okay, right? It's just an implementation detail, I guess, right? But yeah, it's something that I wanted to talk about in case anyone is interested. Okay, so I wanted to show something first before going over with the scale test, and this particle has range 0 and this one has range 2, and there doesn't seem to be any difference at all. As I said, every single particle within the Magicka maps that I decompiled uses range 0. I should decompile more maps to see if they have any other ranges, but like as of now it just looks like they have absolutely nothing to do with the visual effect of the particle. Maybe some internal data for whatever, like maybe it's something like the radius of the locator, which for 90% of cases literally has no use at all. As a matter of fact, I'm saying 90 as a safeguard mechanism, I guess, because as of now I still have not found any in-game use for the radius of a locator, but we will figure it out over time as I keep reverse engineering this stuff, right? But yeah, they look just the same. I'm just recording this in case anyone sees any difference in the behavior of the particle, but even the way that it moves and spawns just looks exactly the same to me. So yeah, maybe it's a phase value of sort, like PHA not FA, you know, so that kind of phase where it changes what phase of the particle it is to look different from others, but I don't see that either. I'm not sure. They all look to be playing the same and at the same time to me. So yeah, not much else to be said about this. So yeah, I have tried doing the scale thing that I mentioned before, and as you can see, the particle, which is supposed to be scaled up by a factor of 2, is actually looking exactly the same as it was before. So that's not cool, but it doesn't really matter. I mean, I guess that explains why there are large variants for the particles, right? So you could, if you want a specific scale, you just copy paste the file, put your own namespace to it at the beginning of the name of the file, and customize the XML file. It's the only solution, right, that I can come up with right now. It's kind of sad, but it's better than nothing, right? Because at least we can get particles going. But it would have been cool if the vector was not normalized. I mean, it's clear that the vector is normalized or maybe only used for orientation, so it doesn't matter if it's normalized or not. So it doesn't affect scale. It's not cool that we cannot encode the scale within it, but it doesn't really matter, I guess. So yeah, there's not much else for me to show, so now I'm just going to dig around and make a bunch of cool particles and show you. Alright, so I tried to put a few more particles, and look at what I got going. So we got the fires that I added before, some fireflies in here, and a particle system for snow. Yeah, pretty cool, huh? I don't know how big this is or where it starts and ends. It seems to be like a really large square. It ends around here, but the origin point for these snow particles is actually over here, right? Sorry, over here. That's where the origin point is located. So I'm guessing it's not entirely centered, but it doesn't matter. It's okay. It looks cool. Looks pretty cool, actually. And yeah, I tried to put a waterfall from the other side of the coin around here, but it crashed, so I had to remove it. I'll have to research why. Maybe some shared resource, or maybe I typed the name wrong. I'm not sure, but this is pretty nice. You can do anything you want pretty much with this, so yeah. Alright, so I got it working actually. Let me show you. So here it is. I was expecting something else, but it makes sense. It's the particle effect for the waterfall in the other side of the coin, where basically, you know, the sort of steam that forms when the water falls at the bottom of the waterfall, you know. So the water moving itself would be a mesh in its own, I guess. So I figured why it crashes, and this is kind of weird. So apparently the thing that did not make use of case insensitive data was the particles. Yeah, I thought it was the triggers or something, but it has to be the particles, because when you copy the name as it is from the particles folder, it doesn't work. But if you make every single character lowercase, it works. So I guess it must make every single file generate a particle with a tag with lowercase names in memory when it loads those XML files, but when it reads it from the file, it doesn't do anything because it most likely already expects them to be lowercase. So we have to write by hand that it's lowercase, or I could just make Python make them lowercase for you. So yeah, that's the thing. I think I said something wrong at the beginning of the video when I said that it worked with both uppercase and lowercase. I apparently was mistaken. But yeah, this is it. Another thing I wanted to show, by the way, let me go 1 minute over to this file, is we can see that these files have different types. We got something like infinite. We got infinite, and rather than continuous emitter, 1 point continuous emitter, right? I don't know what the difference is, but there's also a 2 point continuous emitter, right? Has different blend modes, different shapes. We got the greenish chains, will be cool to see, and we also have stuff with single, which is, you know, stuff that plays one single time, like the ambient confetti. This is the confetti that is thrown at the beginning of the game when they are celebrating the Save the World party, right? So this kind of stuff probably we can play with triggers and events and something. We would have to check the functions used in the in-game XMLs, and we could probably trigger confetti at will, and that would be pretty cool. I'm going to do that one actually. Right, so I edited the thing and we should have confetti going. Let's check it out. So I programmed the confetti to start when we enter this trigger right here, which, as I explained in the trigger video, also plays a clock sound. So that was pretty cool. Okay. Alright, that's pretty nice. So I wonder what happens if we set repeat to true on the trigger. I mean, I guess we could play the confetti many times, but like, yeah, that's pretty much it. We got the whole working trigger system and particle system. We can start making maps with this. You know, animated level parts could potentially be ignored, and you can use triggers to activate checkpoints, and you can start making maps with this. This is actually pretty feature complete as of now. It's missing only the animated level parts, I think, right? Yeah. Anyway, thanks for watching this video. It was actually pretty productive, and we did make quite a lot of progress. Yep.